Hello everyone, in today's video we're going to be going a little bit deeper into methods with classes and actually building our own little functions that can kind of help us out for the purposes of doing a lot of different work. So what I'm going to do is actually take our example from before and actually run with it a little bit because it's a pretty complete example. So let's go ahead and now build my class element here. We'll use everything we've learned so far to be clever. Actually, I'm going to change this to class substance just to be a little bit easier here. So what I'm going to do is I'm going to go ahead and do my classic constructor here. I'm going to do my init here. And there'll be a couple different things I want. I want to use a name. I want to use an element identifier, if I can spell identifier. And of course, I want density, just to kind of keep it nice and easy. So what we're going to do is we're going to be maximum careful here. I'm going to see self.name. We're going to say name. We're going to do a self.element identifier. There we go. Equals element. Thank goodness for that. And of course, self._density. And we're going to go with density here just to make it nice and simple. Super. So what we're going to do now is we're going to go ahead and create some getters and setters. These are basically our accessor methods here. Keep it pretty straightforward. Let's see here. We're going to need a get name. We're going to do self. Make it nice and easy. We're going to turn self._name. Look over there for a second. And there we go. So we've got all of our little handy dandy values for getting all the values out of this class. Remember, with this underscore here, it's just a convention. And we're basically trying to say to the programmer of the future, hey, you're really not supposed to be accessing this directly. Go get it through a different method. Let's go ahead and grab all of our setters as well. These are basically the ones that are going to be setting the values. Again, this is your mutator method. If accessor gets, mutator changes, if you want to think about it another way there. So I'm going to go ahead and do set name. I'll keep it nice and easy. We're going to do self. I'll do new name. Keep it nice and easy. Let's see here. We'll say self._name equals a new name. I'm not too worried about that one. Def here. Let's see here. We're going to do set element identifier. Set element. Oh boy. Identifier. There we go. Fantastic. New ID. This one's pretty straightforward too. So self._, let's see, element identifier equals a new ID. I like that. And here comes the hard one. This is the one we have to be very, very careful with. This is where we're going to have to make sure that the user does not send us a density that does not make sense. Again, one of the reasons why it's nice to have these. Let's see here. We'll do a def. We're going to go ahead and say set_density. We're going to do self. And of course, we're going to do new density. We'll use all that magic we did from last time. If, let's see here, is instance. So we'll keep this nice and simple. New density. String. Let's see here. String. Let me think about that for a second. There we go. I like that a little better. Try to chase down an individual string is going to be kind of a pain. So we're going to go ahead and say self.density, and we're simply going to say new density. All we're saying here is it a float or is it an int? Both of those are perfectly acceptable, so that's perfectly fine for us. Else I'll print a value error, just to let everybody know that you've done something silly. And the other thing, too, is when we do our value error here, we're going to be careful and basically, we're not going to change that density. So it's just going to give you an error in the console here. It's not going to crash or break anything. We could actually, if you wanted to, we could do a raise here and cause an actual error, but we're not going to because we're not like that, of course. So let's go ahead and test our handy dandy little class here, and I'll make sure everything's working fast. We'll go ahead and pick on gold again. Gold equals substance, substance. Okay, so now we need to go ahead and say our different values. I love how it does this. I love gold. This would be AU, and of course, oh my gosh, I forget it every single time. 19.32. Hey, we got it. So let's go ahead and make sure that this works real fast. So I'm just going to try to change the value of gold by typing gold.density.5. If I were to run this, it's basically going to not like me very much. What I've done is I've created a new variable called density, and I've tried to access it. So if I do gold.setDensity, we should be able to feed a value of 5 in here. Nothing bad should happen. Check. If we said, let's say the word hello as our density, check it real quick. Uh-oh, we get a value error. Fantastic. That's actually pretty good. Now, if we wanted to be a little bit better software developers here, what we could actually do is come up here and do an F, and we can actually say what they gave us here. Density is not a proper density value. Nice. So that's a little bit more clear of an error. So now if I ever run this again, you'll say, hello is not a proper density value. Leaving value default. There we go. Whoa, default. And now if I run this one here, you'll see, hello is not a proper density value, leaving value default. Basically giving us a heads up saying, okay, just so I know. But the cool thing here is if I go like this and do 5, and then if I say gold.getDensity, get element identifier, get density, and now if I just run this, well, we got to print it. If I print gold's density, it should say 5. Check. That is not the density of gold. This is just checking. Checking. to make sure it is working. Nice. Everything seems to be pretty good so far. Cool. So now we're all set and ready to go. But what I want to do is I want to build some programs in here, some actual functionality in my class that can actually do things for us, like go ahead and calculate like volume, for example. If I feed it the mass, can it tell me the mass or volume? If I feed it the volume, can it tell me the mass? Oh, that's interesting. Let's see if we can figure this out. So what I'm going to do is I'm going to go ahead and define one. I'll call it calculate, because it's what we're doing, volume from mass. I'm going to need to pass a copy of self. And of course, I'm going to have to set the value of mass. All right, we need to do a mental check here. So in order to get volume from mass, because we already have density, if you're saying, where's my density? Density is right there, Chief. We're good to go. How are we going to do this? Math. I feel like I got to get my little triangle out from chemistry class and work this one out. Let's be lazy. Return mass divided by self._density. Perfect. So what we're doing here is we're actually adding functionality to my class here. We're creating a little method here that's actually going to do some work. It's going to go ahead and if I feed it a mass, it's going to tell me what my volume is. Let's try that. That seems pretty legit. I like that. So let's say here, I'll say mass of substance. We'll see we've got 75 units of it. And we're going to go ahead and say volume equals, we're going to use gold dots. Oh boy. And now all we do is feed the mass. So we're just going to send a mass of substance. And now all we have to do is print volume. Let's see if it works. Volume, and well, let's be professionals. The volume is, and now we're going to say volume, just like that. We'll go press that green flag. Oh, look at that. So we actually know the volume based on the mass that we sent. Wow, that's actually pretty darn useful. I like that. Now, these methods, we can go backwards too. Let's create ourselves another method. Maybe I want to do a calculate a mass from volume. Why not, right? So if I do self, of course, I need to pass volume this time. Now, the cool thing is when I go to do my return, it's super easy. It's just a volume times self._density. Nice. Let's see if it works. So I'll come down here and I'll say volume of substance equals, I don't know, 100. See here, mass of substance, just to keep it kind of simple, just do mass equals, what do we need to do? Gold.calculate. What are we doing? We're calculating mass from volume this time. Volume of substance. Volume of substance. Super. Now if I print, we'll be professionals again, the mass is mass. Let's see if it works. Green flag. Look at that. 1,932 kilograms. Oh, that's quite a chunk there. But you can see how incredibly useful it is. We've actually added functionality. So not only do we have the ability to set values and get values and double check to make sure somebody didn't done goof, but we can actually do things with that actual object, just as we've demonstrated down here. That is really, really useful. Can we go further than that? Heck yeah. So one of my favorite things to do, and again, this is a kind of a C Java thing here, is we can actually have this class tell itself all about itself as a built-in method. I usually call that the toString. So to do that, I'm simply going to come down here and I'm going to create a new function called describe. Or you can also do details, or well, let's be specific. I'll print details. And what I'm going to do is I'm going to pass self. So print, we'll make a nice little thing here. Element name. We'll go ahead and do a comma, self.name, print element symbol. That's a scientific symbol. I always forget what that is. Of course, self, ready for the long one? Element identifier. Nice. Print, let's see here. We'll go ahead and say element density, and we'll do self._density, and let's be professionals here, kg per m3. Fantastic. So now I can come down here, and I can actually do something like this. Gold.print details. Now watch this. If I run it, it runs this nice little text function here that tells me all about the details of that particular instance of that object. And you can see just how handy this is for the purposes of actually building this and doing all your debugging functions and being able to come back and forth. And now we have a really, really nice looking class here that's got a lot of really, really good stuff going on for it. I like this because you can see just how useful it is to be able to kind of add these little functions to it to make it a little bit more powerful in your actual class that it does. Now, the cool part here is we don't just have to make methods that are dedicated to the instance of the class. we can actually make several different types of methods. But that's for another video, because that gets a little complicated. Enjoy.